For 1.9, we're going to look at the measures of variation. And as I mentioned earlier when we met today, the measures of variation are going to talk about how much the data deviates from the mean. And we're going to look at a couple of examples, and a lot of this is really going to be done on Google Sheets. There's not going to be a lot of hand calculation. Truthfully, a lot of that is just going to be a waste of time, because most standard deviations and things like this are going to always be computed using technology of some form, and we're going to use Google Sheets for the sake of our class and to make things a little bit easier. But here we're looking at, right now, two teams, and we're talking about the heights of their starting 5 basketball players. Team 1, we're given the height in feet and inches, and then we just change that completely 2 inches, so 6 foot is 72 inches and so on. And then we have Team 2, and we have the height of that team starting 5 in feet and inches, and then we also have just in inches. So when we compute the mean for these two teams, we find that they both have a mean height of 75 inches. They also have the same median height of 76 inches, and then they also have the same mode of 76 inches. However, we can definitely see that the two teams vary quite a bit, because if you look at Team 1, the height of their players is anywhere from 6 feet tall to 6'6". Team 2 goes from 5'7" to 7 feet tall. So we have to come up with a way to describe in a quantitative manner the discrepancies between these two teams and where we find the differences in them. And when we talk about that, we're actually talking about what's called the measures of variation, or the measures of the spread. So that leads us to our first term that we're going to look at, and that's where we talk about the range. And the range in the data, like I said earlier, is really simple to calculate. You take the largest value and you subtract the smallest value from the set, and that gives you the range or the spread of that data. So for Team 1, the largest height is 78 inches. The smallest height is 72 inches. So the spread on that particular team is only 6 inches. But on Team 2, that spread is 17 inches. And here you can see the calculation range is equal to the maximum value minus the minimum value. The range is really easy to compute, but it only takes into account 2 of the data points. It takes into account the smallest observation and the largest observation. It doesn't take into account anything in the middle. And then we would have to start talking about the interquartile range and things like that. So first we're going to talk about the standard deviation, and we'll get to the IQR later on here when we get to the next set of notes. So the sample standard deviation, it just measures how far on average the observations are from the mean of that particular set of data. And we're going to see the steps through example 1, 2, 3, 4, and finally with 5. And I'm going to do all that on one Google Sheet. So I'm not really going to refer back to our notes too much as far as writing anything down, except unless it's just to illustrate one of the questions that we're looking at. So the heights in inches of the 5 starting players on Team 1 are 72, 73, 76, 76, and 78. Find the deviations from the mean. So to find the deviations from the mean, we have to know what the mean of that set is. So we go over here to our Google Sheet. I need to give us a topic here called mean. So the mean would be just the average. So here I'm going to put average, and that's going to be the average of each one of the individual heights. So the mean is 75 inches. This second column, and I'll tell you what I may do here is, so this is example 1. That is really large. Let's fix that. So the second column is what we're looking at in example 1, and the formula for that is x minus x bar. And if you recall from our previous notes, x bar is the sample mean. X is our individual data point. So the way we would do this in Google Sheets is we would highlight this particular box, and we're going to say equals, it's our data point minus the mean, and just hit enter, and we get -3. And then we can do that for the remaining points on down through here. So it's equal to this minus the mean. And rather than having to type that in each time, there is a shortcut that we can do. We can type in equals this data point minus the mean. But on the mean, since we're using that same value over and over and over, if you put a $ between, in this case, B and 10, what it does is it locks that point into place, and so now we can actually drag this down, and it calculates that difference each individual time. If you're not comfortable with that, or if I need to explain that further, we'll do that in class together. But in the meantime, if you're not comfortable using that $ to hold a position in place, just do it individually, one point at a time, and then we'll talk about it on Wednesday. The second part of this, so our answer to example 1 is find the deviations from the mean, and this column right here represents the deviations from the mean: -3 inches, -2 inches, 1 inch, 1 inch, and 3 inch. The second column is our example 2. So if you look back at your notes, example 2 is asking you to find the sum of the squared deviations for the height of the starting players. So the first thing we want to do is equal, click on this value, and then we're going to square it. So you use the caret symbol, squared, and hit enter. And then if we want to complete that formula all the way down our list, we just drag this down, and each one of our values has been squared. So -3 squared is +9, -2 squared is 4, 1 squared is 1, and so on. This question, though, is asking for the sum. That's why we have that sigma right there. It's the sum of all these values. So we just take this column and we type in equals sum, highlight our values, and we get 24 inches. That actually is 24 inches squared for example 2. That's what that result shows us. So for example 2, we have calculated the sum of the squares of the differences, but we need to come up with the variance of the height. So the next step is this example 3. So let me type that in. I should have done this earlier, but that's example 3, and the formula is s squared. So that's the square of the variances is equal to, pretty much it's this sum of x sub I minus x bar quantity squared is this value right here. Maybe if I highlight that, it'll help. Okay, that is that numerator. The sigma x sub I minus x bar quantity squared is 24. This n minus 1, n is the number of data points that we're evaluating, minus 1. So in our case, we have 5 data points. We have 5 individual heights. So our answer to example 3 is going to be, we can type in equals, tell you what, let me put it down here next to this. It's going to be equal to this value divided by 5 minus 1, or you could just put 4, but I'm just using the formula. It's n minus 1, and we get 6. So we get 6 square inches is the deviation, or the sample variance rather. Then it's just one more step to come up with the standard deviation. The standard deviation is the square root of our result from example 3. So we could just type in equals square root of this result, and we get 2.4494. All right, that is the kind of the long way around coming up with the sample standard deviation. That's the result in example 4. In example 5, we want to do the same thing over again, but this time we're just going to use Google Sheets to calculate it. So here, rather than going through all these steps, let me type this out again. Sample. In Google Sheets, you can simply just type equals, and if you start typing standard deviation, STD. So standard deviation. So these two options right here, you have stdev.p, and stdev.s. .p is for the standard deviation for population. .s is for a sample, so we're going to use stdev.s. We highlight our values, close the parentheses, hit enter, and you can see it's the exact same calculation as what we had before. There is a difference. Let me just show you real quick between the population standard deviation and the sample standard deviation. So again, we'll go STD. We want population. If I highlight these values, you can see that the population standard deviation is 2.1908. It is different, but that is, of course, assuming then that these 5 values represent the entire population of what we're looking at. But we know, because it's given as a sample, that that's not the case. So when you're doing these on Google Sheets, please be careful to make sure you select the correct value for the standard deviation, which would be the sample standard deviation. So if I go back to the notes here, we're going to go examples 1, 2, 3, 4, and 5 were answered on the Google Sheet. Then we have this computing formula for the standard deviation. And that's one of those things that I say we really won't utilize in this class a whole lot. And that's for example 6. And we came up with the exact same value that we did using Google Sheets. So some of the rounding basics. It's very important not to round your values too soon. Do not round any of your numbers until you get to the end of your calculations. So if you're doing Google Sheets, just let Google Sheets maintain all of your rounding or all of your decimal values until you get to the end. You can see on our standard deviation, it's 2.449489.743. You're not going to give that as a value for your standard deviation. The traditional rule of thumb is you go 1 decimal place more than what you have in the raw data. And so each one of our data points is going to be 0.0. So what we would have then for our standard deviation is 2.4. If this was 72.3 and this was 76.4, for example, then we would go 1 more decimal place beyond that and we would have 2.45. But for our purposes for this question, it's 72.0, 73.0. So there is nothing after the decimal. So we would just go 1 decimal place beyond that and we would get 2.4 as our sample standard deviation. Try to see the 3 standard deviation rule. That's back on our notes. 3 standard deviation rule. Almost all of your observations in any set of data lie within 3 standard deviations to either side of the mean. So in our example for the heights, standard deviation is 2.4 inches. The mean is 75 inches. So we would have 75 inches in the middle. We would add 2.4 inches to the right, and that takes us to 77.4. We would subtract 0.4 inches from the 75, and that would take us 1 standard deviation to the left, and we'd have 72.6. So let me write this out or kind of draw a picture for you, because we're going to think about these things in terms of a normal curve. So our mean was 75 inches, and our standard deviation is 2.4. So 1 standard deviation to the right, we would add 2.4, and that takes us to 77.4. Then we would add 2.4 again, and we get 79.8. Add 2.4 again, and we would get 82.2. And then in the same fashion, we would move 3 standard deviations to the left, so we would subtract 2.4. So the first one gives us 72.6. Then we subtract 2.4 again, and we would get 70.2. Subtract 2.4 one more time, and we would get 67.8. So that's 3 standard deviations to the left, 3 standard deviations to the right. Approximately 100% of your data is going to lie between 3 standard deviations. So from here to here, it's actually it's 99.7% is what the actual calculation works out to be. You may have that 0.3% of your data may lie beyond 3 standard deviations to the right or 3 standard deviations to the left of the mean. But that's what the standard deviation is showing you. It's you have a fixed value of data that lies one standard deviation to the left or right of this mean. You also have a fixed percentage of data points that lie 2 standard deviations to the right and 2 standard deviations to the mean. And then continue on, we have a fixed value of the data that lies 3 standard deviations to the right and 3 standard deviations to the left. So there's your homework problems. I would recommend just using Google Sheets for everything. Put it on a Google Doc, send it to me, and you guys will have this one knocked out and finished up. If you have questions, remember to ask me. I hope that this makes sense, but again, like I said, when we meet on Wednesday, I will clarify some of this because I know we kind of went through a few things pretty quick, but this should get you a good starting point. Hope everybody's having a great day, and I'll be talking to you soon.